into good hands, CBDC could give governments powerful tools for better governance, but put into bad hands, they have the potential to create a horrible cyberpunk dystopia. But whether you like them or not, CBDCs are one of the big trends in crypto in 2023. So in this video, I will explain what is a CBDC and I will show you how to code one in a Solidity smart contract. If you're new here, I'm Julian, and on In The Blogs, I help you to become a professional Web3 developer. I've been in the Web3 industry for many years, and I've helped many developers to get started in Web3. And if you want to know how to get started in Web3 and get your first job, check out my free masterclass. The link is down below. So what is a CBDC? So CBDC means central bank digital currency. This is supposed to be a replacement of fiat, but on the blockchain. This is controlled by governments, and this is implemented with a stable coin on the blockchain. But which blockchain? Probably not a public chain. Most likely it will be a private chain that doesn't exist yet. Which technology it's going to use, we don't know yet, but it's very likely that CBDC will be implemented with the EVM, which is a technology of Ethereum. Ethereum is very modular and you can pick and choose which part you want. So you can take the EVM without taking the proof of stake consensus. For government, the big advantage of CBDC is that it can give them very fine-grained control over their economic policy, which means that they can be very efficient. But it also has some downside because it gives government even more power over how you spend your money. So it's really a double-edged sword. It can go both ways. Is there any CBDC that already exists? CBDC are actively tested in 2023. A lot of central banks are working on that, and we're expecting the first CBDC in production this year. So you have to keep an eye on this because it's going to be a part of the blockchain industry, even though it doesn't go at all in the direction originally envisioned by the community. But there might be a lot of job opportunities around CBDCs in the future. All right, so we are going to start to code our CBDC. And so for that, we're going to need a language called Solidity. So that's the most popular programming language for smart contract on Ethereum. And for that, we're going to use a tool called Remix. That's a coding editor for Solidity. And so you can find it online at remix.ethereum.org. No need to install anything. And so when you arrive there, the first thing will be to configure the version of Solidity. So we're going to take the latest one, 08.19. Here, make sure that autocompile is activated. So we're going to have live feedback. After, we're going to go in the File Explorer and we're going to create a new file. So let's call this cbdc.sol. So .sol, this is the extension for Solidity smart contract. And so after that, we are going to start the coding. So first we are going to specify the version of Solidity. So 0.8.19. So next we are going to import the OpenZeppelin library. So this is going to give us a basic functionality for our CBDC. So on the blockchain, one of the most common way of representing asset is with the ERC20 standard. This is a standard that defines a set of functionality of what a token should have. And OpenZeppelin is a Solidity library that is widely used because it contains a standard implementation of ERC20. So this is best practice to use it when you create an ERC20. So this is what we're going to do. So we use the import statement to import the code. And so this is the OpenZeppelin package. And after we specify the path to the token, so we terminate our statement with a semicolon, like all statement in Solidity. The next, we are going to define our smart contract. So contract CBDC. And after, we're going to inherit from ERC20 of OpenZeppelin. So we're going to use the is keyword for that. And so that means that we inherit from all the functionality of ERC20 of OpenZeppelin. So it really reduces the number of line of code. And after, we're going to define a couple of state variables. So you use state variables when you want to store data in the blockchain permanently. So you can see addresses like a bank account number. This is used for wallets that are controlled by people and also for smart contract. Specify that this is a public variable, which means that it can be read from outside the blockchain. And first, we're going to have a controlling party. So that's basically the government. After that, we're going to define an integer with the uint keyword. And this is going to be for the interest rate of our CBDC. And this is going to be equal to 500 basis points, which means 5%. If you've never heard of basis point, this is a unit that is commonly used in finance. So after that, we are going to define a blacklist. This is going to be a list of addresses that cannot move their money. So here a mapping is a key value store. So we have to specify the type of the keys and then the type of the value that they map to. So they're going to map to Boolean value. And this is going to be public blacklist. After that, another mapping of addresses to integer. So this time it's going to be private. And so our CBDC will allow participants to stake their coin. So by staking your coin, you're going to be able to get the interest rate. And this mapping is going to tell you how much you've staked. So here, let's call this stake treasury bond. After that, we're going to have another mapping of addresses to integer again. It's going to be private. And here we want to store the timestamp from which we started the staking. After that, we're going to define a couple of events. So events allow you to keep track of all the data change that you do. Because at any time on the blockchain, you can only read the latest value of a variable, but it can also be useful to keep track of the changes. So you emit event. These events aren't stored on the blockchain, but they can be listened to from outside the blockchain, and you can reconstruct the history of the value change. So here we're going to define our event. Update controlling party. So every time we change the controlling party, this is going to be emitted. And we specify the member of this event, so all controlling party and new controlling party. All right. After that, another one, update interest rate. So every time we change the interest rate, and we want to keep track of the old interest rate and the new one. All right. After that, an event when we increase the money supply. So the controlling party will have the ability to mint some coin for itself, and so that it can be used for government spending. And here we want to keep track of the old money supply and the new amount that was minted, inflation amount. All right. And after that, another event is going to be the update of the blacklist. So which criminal we added to the blacklist, and if he was blocked or not. And after that, another event when we stake some treasury bond. So address of the user and how much we staked. And after that, another event when we unstake. And after that, another event when we claim our treasury bond. So basically when we get the money from our staking. So the address of the user and the amount that was unstaked. All right, so we have all of our variable and our event. So next we are going to define a constructor. So this is a special function that is executed only once when you deploy the smart contract. So we specify the address of the controlling party and then what is the initial supply of our coin. We're also going to execute the constructor of the ERC20 of OpenZeppelin. And so we pass it different parameters. So first, a string that define our assets. So central bank digital currency. And after the ticker, so an abbreviation of the asset that is used in exchanges. And after that, we're going to define what happened. So here we update the controlling party variable. Right, and after that we are going to mint the initial supply. So here underscore mint, this is defined in ERC20. So even though we haven't defined it ourselves in our contract, we can still use it because we inherit from ERC20. And so here the recipient will be the controlling party, and here the initial supply. All right. Now we have our constructor. So next step is to create first function, and we need a function to update the controlling party because it's possible that the address of the government will change. So here we need the new address, and here we specify that this is an external function, which means it can be called from outside of the blockchain only. And so first we need to do access control. We need to make sure that the sender of the transaction is the government, otherwise anybody can trigger this function. And the error message is you are not the controlling party, right? After we update the value, new controlling party, all right? And finally, we are going to transfer all the coin to the new controlling party. Here we use the underscore transfer function of ERC20. So the first argument is the from address. So controlling party, by the way, this is an internal function, so it's perfectly safe. It's not possible to call underscore transfer from outside the blockchain and decide any from address that you want. So here, controlling party, the second one is the new controlling party, and the amount will be the balance of the controlling party. So balance of, this is another function of ERC20, controlling party. All right, so let's terminate this statement. Okay, so after we need another function for updating the interest rate, because this will change over time. So we need to specify the new interest rate. Okay, this is going to be in basis points, right? This is an external function also. And here we need to do some access control also. All right, let's put this uppercase. So here, another protected function. After that, specify, we're going to save the old interest rate because we need for the event, old interest rate basis point. So interest rate basis point. Okay. And so after we can do the actual update. So interest rate basis point, new interest rate basis point, and then we emit an event. So we emit an event with this keyword, emit update interest rate, and here we're going to specify the old interest rate and the new one, new interest rate. Okay, awesome. And I realized that we forgot to emit an event for the previous function, so let's do this now. So it's update controlling party, and so the old one is the sender of the transaction, and the new one, new controlling party. Okay, cool. And so there is an error, line 32. Okay, here we need to make this lowercase, otherwise it thinks that we're trying to redefine an event. Okay, so that is fixed. Then we are going to do another function to increase the money supply. So basically when government want to print money, this is the magical function, the money printer. So here we specify what is the amount of inflation, the amount of new coin. Here this is external. So here we need some access control because otherwise anybody can print as much money as they want. We are going to store the old money supply for the event we're gonna emit just after, and for that we use the total supply function of ERC20. We are going to mint some new coin, and so the recipient is going to be the controlling party, so MSG sender, and here inflation amount, and finally we emit the event, emit increase money supply, old money supply inflation amount. All right, so next we're going to do a function to stake our coin. So stake treasury bond. And so we need to specify what is the amount. So first we need to make sure that the amount to be staked is superior to 0. So here the amount is inferior or equal to 0, so it's not okay. Then we need to make sure that the balance of the user is enough to stake this amount. So here it needs to be superior or equal to amount. And the error message after balance is inferior or equal to amount. So you cannot stake, you don't have enough money. We are going to transfer the coin from the sender to the address of the smart contract. So it's going to be locked, and this is going to be for the amount specified. And if we already have some stake bond, we are going to claim them. So we haven't implemented this function yet, but we're going to do it after. All right, and why is not happy? Oh yeah, because the function doesn't exist yet. Okay, so we're just gonna create the signature just to fix this. Claim treasury bond, public. All right. So here we make it public because it can be called from outside the smart contract, but also from inside. So if we make it external, we won't be able to do this call here. And the reason why we have to claim a treasury bond here is because we are going to change the amount of treasury bond that is staked. And so claim treasury bond assume that the amount that was staked was the same during the whole period. Otherwise, the calculation becomes too complicated. So here, before we change the previous amount stake, we just claim the treasury bond for the whole period. And after that, we are going to update our mapping. So stake from timestamp mapping, and we're going to update it at the current time. After, we're going to update the stake treasury bond mapping. So we're going to add the amount that we want to stake. And finally, we're going to emit the event stake treasury bond, MSG sender amount. And that's it. So we have our staking function. Great. So next step, we are going to create the opposite function, unstake treasury bond. And we also need to specify how much we want to unstake. And so the first require will be the same as before. After, we're going to require then the stake treasury bond of the sender is above the unstake amount. Amount is superior as to stake. Okay, so here let's close this. Here again, we need to call claim treasury bond. So for the same reason as before, every time the amount of stake coin will change, we need to claim our reward before, because it can only work with the same level of staked coin for easy calculation. And after that, stake treasury, we're going to update our mapping. So stake treasury bond of the sender, and it's going to be decremented by the amount. And we're also going to give back the coin to the user. So we take it from the address of the smart contract, send it to the user, and for the amount that was unstaked. And finally, we emit an event, unstake treasury bond, and we specify the sender and the amount. All right. Here, okay, there's a typo. All right, this is fixed. Cool. So we have an unstake function. So next, we're going to implement claim treasury bond. So that's the function you use when you want to get the benefit from your staked coin. First, we need to make sure that you have something staked. So let's copy this. Stake needs to be equal to 0, strictly superior. And here the error message is staked is inferior or equal to 0. So there is nothing to claim in this case. And here we need to calculate the duration during which it was staked. So here, this is the difference between the current timestamp and the timestamp that was originally in the mapping. And after, we're going to calculate the reward here first we need to know how much was staked by the sender, and we're gonna multiply this by the duration during which it was staked and multiply by the interest rate. And then we need to do some division. So first we need to transform the interest rate in basis points. We need to normalize it, so divide it by 10,000 because 1 basis point is 10 power minus 5. And after, we also need to divide this by the number of seconds in a year because the interest rate is given per year. And here we have second. And so for that, we're going to multiply by the number of seconds. So it's about 31 million. So 33.154 power 7. So you can do the calculation, but you'll see that it's roughly this number. All right, so let's terminate this statement. Okay, so we have our reward. After that, we need to update stake from TS mapping. Okay, MSG sender, because everything reset basically for the next calculation. Then we need to give the reward to the user, and so this is going to be minted. So it's also going to increase the total money supply. And here we give it the reward, and after that we emit an event, claim treasury bonds, MSG sender rewards. All right, our claim treasury function is completed. We have one last function. So we need to override the underscore transfer function that is provided by ERC20 because of the blacklist feature. And so here we're gonna specify the argument. So from to address and how much needs to be transferred, and this is internal, so cannot be called from outside the smart contract. Virtual override, so this is the keyword of Solidity to say that we override the function of the same name that was inherited. And first we're gonna make sure that this sender is not in the blacklist. Here the error message, and same thing from the recipient. It also needs to be outside the blacklist. And after, we are going to call the underscore function underscore transfer of ERC20, and for that we need to use the super keyword called the other underscore transfer defined by the parent. And here we just forward all the argument from to amount. All right, okay, cool. And I think we actually forgot one function for the blacklisting. Let me see. All right, so here let's add a function for the blacklisting. Update blacklist. Okay, so here let's give the address of the criminal, then how much. No, there's no quantity, it's black or white. And here if it's blacklisted or not. So we can use the same function to blacklist and unblacklist. Of course, only the controlling party can call this. And here blacklisted and of the criminal and blacklisted. All right. And we need to emit an event, update blacklist, and here criminal blacklisted. All right, and blacklisted, maybe this is not this mapping. Let me see. Okay, it's just called blacklist. Here blacklist. Let's close this, and we're good. And for the next step, if you want to become a professional Web3 developer and find your first 6-figure job in the industry, check out my free masterclass. It will give you a complete roadmap. The link is just down below. That's it for now. Bye.